Hello! Today we will be starting with a question. Say we want to select members for leadership positions in a club. The first person will be the president, the second person will be the vice president, and the third person will be the secretary, we'll say. And the club has a total of 15 people, so we want 3 people from the group of 15. So, I'll give you a moment, see if you can figure this out. So, what we need to figure out is how many different ways we can take the people from the group. So for the first position, for the president, we can take, there's 15 people. Now somebody's been selected, so for vice president, there's only 14. And then for the secretary, because 2 people have been selected, there's only 13. So this sequence should be reminiscent of factorials, how we're multiplying by decreasing by 1 each time. So how do we get from the factorial of our total, in this case 15, to just 15 times 14 times 13? The way that we do this is by dividing off the unwanted terms. So it would look like 15 factorial over our unwanted terms are 12 times 11 times 10 times 9. And this on, and so on, down to 1. And that again is another factorial, so this is also equal to simply 15 factorial over 12 factorial. So, and then 12 is the number here less than 15, so now we have derived the formula for permutation, which is n times pk, as the resource guide puts it, equals n factorial over n minus k all factorial. That's exactly what we did up here if n equals 15 and k equals 13. So what other ways could we use this? This is used whenever we want to take a certain number from something and the order matters. So in this case, the different people or different positions. For if we don't want order to matter, say if we're selecting members of the committee, we'll use combinations, but we'll go over those later. First, let's do a practice problem. Say when order matters, we want to take 7 books off a shelf of, let's say 8 books. So how does this work out? I'll give you a moment. Okay, so the way we will solve this is we'll do n equals 8 and k equals 7. So we have 8 pk, which equals 8 p7, which equals 8 factorial over 8 minus 7 factorial, or 8 factorial over 1 factorial, which is 1, so we just get 8 factorial. And if we want to put that into the calculator, we'll do 8, you remember, all the way over to probability, and factorial. So 40,320 different ways to select those books. Now, what if we don't want to go through the formula the whole time, as is very important when time is on the line, as an ACDEC? We can do permutation with our calculators too. It's in the exact same menu as factorial, and it's just under probability, and then it's the second one down, NPR, and not the radio station. The calculator uses NPR, the resource guide uses NPK. And I believe we just do 8. So we put our number in, then we do NPR, and then we'll do in this case 7, and we get the same answer. So put your number in, navigate over to probability, do NPR, and put your next number in, and you get your number out. So we'll do one more practice problem. Say we're selecting the computer files in a slideshow. Well, we're setting the order of a slideshow. We'll say we have 13, there'll be 13 slides in the slideshow. So we have k equals 13, and people have submitted 200 slides, so n equals 200. You're not gonna wanna solve this one by hand. So, doing this in the calculator, we start with our first number, 200, and we go over to probability, down to NBR, and type in 13. And we get out a very large number of different presentations we can make. Okay, that is all for permutation. In the next video, we will cover combinations. Thank you.